Okay. Today's our topic is antenna apertures, antenna efficiency, and effective height. In our last classes, we covered all these topics: antenna fundamentals, introduction, radiation mechanism, single wire, two wire, and what is a dipole antenna, and antenna parameters. What different types of radiation parameters, patterns in principal planes. Okay, main, what is a main lobe, what is a side lobe, back lobe, beam with polarization, beam area, radiation intensity, efficiency, directivity, gain, and what is the resolution. All these parameters, antenna parameters, the basics of the antenna fundamentals, which we have covered in last classes. So in our first unit, the last topic is antenna apertures, antenna efficiency, and effective height. So right now, today in this class, we will discuss what is an aperture and what is aperture efficiency and what is effective height, and what are the equations and regarding these parameters we can see, right? So let start with our discussion with an effective height, or that is antenna height. So effective length or antenna height. So effective length is the ratio of induced voltage at the terminal of the receiving antenna under open circuit condition to the incident electric field intensity E. So basically, suppose if you look at this diagram, so effective length or E, the length of the current, effective length equal to open circuited voltage V by incident field strength, that is electric field strength. V by E is nothing but effective length of the antenna. It's very simple. So the what is again effective length of the antenna is nothing but it is the ratio of in open circuit condition, ratio of induced voltage at the terminal of a receiving antenna under open circuit condition to the incident electric field. Okay, normally uh, the concept of aperture is most simply introduced by considering a receiving antenna. Whenever we speak about aperture of the antenna, we consider it is a receiving antenna. So suppose that the receiving antenna is a rectangular electromagnetic horn in the field of a uniform plane wave. Okay, so then the antenna aperture can be denoted as, I will draw the equations, right? So what is the this one length of the antenna? Length of antenna. The length of the antenna is nothing but length of the antenna is equal to voltage induced in open circuit condition V by the incident electric field strength E is nothing but the length of the antenna or antenna aperture. Normally we speak. So another definition, another parameter, antenna efficiency, antenna efficiency or aperture efficiency. Again, students, please remember, whenever we talk about aperture, it is mostly common to receiving antenna. Receiving antenna. What is the meaning of aperture means? Aperture means available space. Available space. So, how can we define aperture efficiency? Aperture efficiency is denoted by epsilon. Aperture efficiency equal to, so the aperture is denoted by capital A, that is A suffix E, that is effective aperture. Effective aperture of the antenna to the physical aperture of the antenna is nothing but aperture efficiency. Aperture efficiency. So, uh, what is that one? First one, that is antenna height, length of the antenna. Effective length of the antenna or length of the antenna is denoted by L effective equal to V by V by E. V by E. As per the technical specification, you can write like this. Length of the antenna L effective equal to V by E. And efficiency, aperture efficiency epsilon AP, A suffix AB equal to A suffix E. The total aperture by available physical aperture is nothing but aperture efficiency. So normally whenever we talk about aperture, it is related to a receiving antenna. Why? Because suppose if a antenna is propagating like this, suppose it is a horn antenna, all right? It is a rectangular horn antenna. So suppose if it is a transmitting antenna, it's in the same way there is a receiving antenna is also there. So aperture means uh, the amount of power it is receiving by a receiver antenna. So suppose this transmitting antenna delivering some electromagnetic waves or some radiated power is radiating. So the available power received by this transmitting antenna is explained in terms of its aperture. The aperture means available space, available area. So this is about the length of the antenna and antenna aperture antenna efficiency or aperture efficiency. Aperture efficiency. Now we look at into the some another parameter, effective area, effective area or effective aperture. What is just now I told aperture means available space. So what is the effective available space? This is nothing but effective area which is available to the receiving antenna. So in general, I will write the equations here. Effective aperture or effective area. Okay, this is our topic, right? Effective aperture or effective area. So in general, this term is used in relation with, already I told, this term is related with a receiving antenna. Receiving antenna. So aperture is related with a receiving antenna. So effective aperture, that is A suffix E, equal to the effective aperture. How can you define this? Is the ability of the antenna to extract energy from an electromagnetic wave. So it is called an effective aperture or effective area. So it is defined as the ratio of power received in the load, power received in the load by power average, power average power density at that point, average power density at that point. So units is meter square. So power received by an antenna may be denoted by P suffix R. It is measured in watts. The power density is measured in watts per meter square. The that is average power density is denoted by P suffix average is denoted in terms of watts per meter square. Hence, the units for effective aperture is simply meter square. Simply in meter square. In other words, we can explain effective aperture as an area which extracts energy from electromagnetic wave. Very simple thing. Suppose if this is an antenna, it is delivering some electromagnetic wave. This is one receiving antenna. So, in other words, we can explain, or how can I explain effective aperture of as an area which extracts energy from this electromagnetic waves out of the total area of the antenna. Okay, out of these electromagnetic waves, all the waves are not extracted by this receiver antenna. Okay, this antenna is delivering some electromagnetic waves. So this is the total electromagnetic waves. So in this total electromagnetic waves, this receiving antenna may extract some of the electromagnetic waves here. So that is the available electromagnetic waves. So that is nothing but aperture. So obviously, what is going to an antenna have a maximum useful area to extract energy. So suppose this is the a receiving antenna, it is having some useful area to extract energy from the space, from the electromagnetic waves. So thus the maximum effective aperture is obtained. The maximum effective aperture is obtained when the power received is maximum. When the power received is maximum. Suppose this transmitting antenna delivered the maximum power in some directions. Okay, suppose here is the maximum power, here is the maximum power, here is the maximum power. So when the maximum effective aperture is obtained is when the power received is maximum. Obviously, when receiver antenna is having more power received, automatically it is having more aperture. So it is denoted by A suffix EM. In general, antenna has a certain impedance which is made up of a resistive and reactive part. The resistive part of the impedance is nothing but, I will write in this one. Suppose I will draw this entire antenna system in terms of some circuit parameters right now. So the source of the antenna, that is our supply, that is VOC. Okay, so in general, antenna has a certain impedance which is made up of resistive and reactive parts. So this is one thing, and this one is the load. So this is a circuit. Okay, so current flows in this direction. Here the electromagnetic waves may flow. So here Z equal to R radiation resistance plus Jx. Here the load equal to R radiation minus Jx. Okay. So by using maximum power transfer condition, the power received is maximum and hence effective aperture is maximum. So here the point is where the effective aperture is maximum means where the power received is maximum. So it is just like a maximum power transfer theorem, which we studied in electrical circuit. So we can move into the derivation part right now. Coming to the derivation part, I will draw a separate diagram first. All of you please look at. R radiation plus reactive part, R radiation plus imaginary part. This is VOC. So let us calculate effective aperture of for an Hertzian dipole. When the Hertzian dipole is used as a receiving antenna, that is, this circuit is a receiving antenna, it extracts power from the incident waves and delivers it to the load. Load is nothing but which is at present in the receiving antenna, producing a voltage on it into the it. So the equivalent circuit is shown here. Now the voltage induced in this antenna, particular antenna, is nothing but VOC equal to the electric field strength is a vector quantity E into dl. So here, what is the dl? Where E is the magnitude of the electric field intensity produced at a receiving point, and the dl is length of the Hertzian dipole. Length of the Hertzian dipole. So then the current flowing, the current flowing the load is given by I equal to VOC by the total resistance or the total impedance. I equal to V equal to IR. So from that one, I equal to VOC by Z plus ZL. So for the maximum power transfer condition, load is selected as the complex conjugate of the antenna impedance. So substituting these values Z plus ZL, we get I equal to VOC by 2 radiation resistance. I will write directly. So plus jx and minus jx will be cancelled, and r radiation plus r radiation, you will get 2 radiation. So next one, then the power delivered to the load, then the power delivered to load is given by, which is denoted by P suffix r. P suffix r. So if this P suffix power is having one formula, I RMS square, I square RMS into R radiation resistance. So I square RMS is having a formula I by root 2. So I by root 2. Here I use nothing but VOC by 2 radiation by, this is I by root 2. So this is I square into radiation resistance R. So this is the power delivered to the load. Power delivered to the load. So from this one we get P suffix R equal to, so VOC square by 8 radiation resistance. So substituting VOC value in the equation where VOC, we get, so finally we get power radiation P suffix R equal to E square into DL square by 8 into R radiation resistance. This is one. You please note this one. So as per the definition, effective aperture, effective aperture, maximum power received by average power. Already we read the equation in previous session. So P suffix R by P average. So So we get P suffix R is this one, and P average is nothing but of there is a formula. So by substituting these values, so P average is equal to 1 by 2 epsilon E square by eta naught. So by substituting P average equal to this equation and P suffix R equal to this equation, finally we get effective aperture E A suffix EM equal to 1.5 lambda square by 4 pi. 1.5 lambda square by 4 pi. So this is effective aperture of an Hertzian dipole. So this is the derivation of effective aperture for Hertzian dipole by using with reference to a maximum power transfer. Maximum power transfer. Now, as per our first unit, if you please, if you observe, aperture, antenna aperture, efficiency, effective height, directivity, gain, beam efficiency, radiation intensity. So all the parameters is over. So in our next class, I will sort out and write all the parameters and the equations by drafting in one A4 sheet. I will put into the. I will post in your group, right? So this is what aperture. Aperture is nothing but aperture is purely we speak about a receiving antenna. So I will write some of the formulas which is useful in the calculation of the problems. So for aperture only, aperture beam area relation. Aperture beam area relation. So aperture is AE equal to lambda square by beam area omega A. Okay, and the directivity from aperture, and D equal to 4 pi into AE by lambda square. Okay, so these are the apertures which is from a directivity from aperture and aperture beam area relation. So as we know, directivity formula be equal to 4 pi by something in our last class. So by substituting these values, we will get this one. So all of you please go through these formulas frequently. Then only we can understand the formulas and their interrelations. Without good practice, we can't do anything, right? So effective height of the antenna, which is denoted by L effective, length of the effective is what? Voltage induced by electric field strength. Some of the textbooks may write H height or length of the effective aperture or length of the effective antenna, like this. Okay, this is about the one. So here this is about first unit. Okay, all of you please follow the antenna parameters, all the antenna parameters. Okay, we will look at into the problems from the next class onwards. We are moving into the second unit. Thank you.